All right. Well, those of you who are with us, obviously I'm Mr. Mounts, and we have an awesome guest here, former YHS student, Austin Prater, who works in the aerospace industry and is here to talk to us quite a bit about his career path and what you need to do if this is an interest of yours. So I don't want to take any of his spotlight away, so I'll let him kind of introduce himself a little further and get going with his presentation.
Cool. Thanks, Mr. Mounds. Well, yeah, looking forward to being here. So I'll kind of just talk about who I am, what my industry is, where I work, and then I think we'll just kind of have an open Q&A. I can show some photos and talk about some of the cool stuff that we do, and then I'm happy to answer any questions you guys have. So I'm actually a YHS alumni. I grew up in Yelm. I lived there from about 2001 and then graduated in 2013. I took class with Mr. Mounts, so that's a kind of a throwback. It's pretty cool to be here now. And so after I graduated from Yelm, I went to Cal Poly SLO, which is in Central Coast, California. I studied aerospace engineering, and I did my concentration in astronautical engineering, which is kind of like more space focused. You have aviation, which is aeronautical, and then you have astronautical, which is spacecraft, rockets. And so after graduating with my bachelor's, I went and I worked and still work at this company called Phase 4 in Los Angeles. And Los Angeles is a pretty big hub for aerospace, along with Denver, along with Seattle. Those are kind of where a ton of those aerospace companies are focused. And I think Yelm rocks, and I miss the Casamia pizza because. So just for reference, Los Angeles, again, big aerospace hub. We're a pretty small company relative to, generally when you think aerospace, I think a lot of people think Boeing, Northrop, Raytheon, those huge mega corporations. And so we're actually about a 20-person team, and it's sort of called new space. It's this side industry in aerospace where there's kind of this new emerging technology where there's a lot of young companies that are growing in the aerospace sector, doing things that wouldn't be cost beneficial for Northrop or Boeing or these other groups to try and pursue. And we mostly focus on propulsion systems. So what do I do? And I'll go into what our propulsion systems are as well. I'm an aerospace engineer. That's my title. So again, we focus on a lot of propulsion systems for spacecraft. And so I guess my day-to-day responsibilities, because our company is so small, everybody wears a lot of hats. I think that's kind of unusual for aerospace. Going back to like the Boeing analogy, if you're at a big company, maybe you'll be focused on some very particular projects, but it's been a unique situation for me being at the smaller company because we all get to do a lot of different things day to day just because of the size of our team. And, it takes a lot to send stuff to space. So everybody gets to kind of dabble in a bunch of different subjects, which is a really cool way to approach aerospace. So a lot of my day-to-day responsibilities, mechanical design, CAD, simulation, that sort of thing, environmental testing. So when you're wanting to send something into orbit or when you're wanting to launch some hardware, you want to obviously ensure that it's going to survive and that you don't want to spend all this money just to have it fail on launch or have it fail, after a couple of weeks on orbit. So we do a lot of environmental testing. Maybe we'll go and put it on a shaker table and we'll do vibration to simulate what the launch vehicle is like. We'll do thermal cycling because when you're in orbit, you're exposed to the sun and then you go back behind the shadow of the earth and you're cold. And so there's a lot of big thermal gradients that can thermally shock your hardware. So we do a lot of that sort of testing. I focus a lot on systems integration as well. If I have this subassembly and I want to mate it to this other subassembly, how are they going to play? What are my power restrictions? Because it's not like I can just plug into an AC outlet in space, right? You have limited power, you have limited energy to work with. So systems is a big part of it. For all space programs, systems is a big part of it. And then I also do a lot of pre-launch support. So going to Cape Canaveral for fueling operations, working with our customers for integration, that sort of thing. Now, propulsion. So I think a lot of the time when people think propulsion, you think about kind of the sexy stuff like SpaceX and the launch vehicles and that sort of thing. But there's another aspect of propulsion, which is on-orbit propulsion. And so virtually every spacecraft, or not every, but most spacecraft that are in orbit rely on some form of propulsion system, so that once they're in orbit and separated from the launch vehicle, the rocket, they can maneuver, they can move around if they need to maybe avoid another spacecraft. So, with the huge growth of the aerospace industry over the past couple of decades, more and more satellites going up, there's always going to be collision avoidance is a big deal. Also, there's still a little bit of drag. There's environments in space that'll affect you that can change your orbit. So if you want to be in a certain spot but you're drifting away, then propulsion helps you to get back into those, your desired orbit. And also, obviously, if you're going, say, interplanetary, or your mission is further away than just an Earth orbit, then propulsion helps you do that. And so some programs that are, I guess, impact us day to day, that satellites use and that rely on propulsion. GPS satellites constantly have to maintain their orbits. They require very precise orbital positions. Internet, especially with new programs like SpaceX's Starlink. If you don't know what Starlink is, I encourage you guys to look it up. It's a pretty cool program that SpaceX is doing for global internet. There's a couple other companies that are doing similar things. Satellite imagery, Google Earth, Google Maps. There's a lot of companies that are doing imagery that helps us every day. Earth weather, observation, communication. So as you can tell, propulsion is definitely important for our day-to-day lives, because it allows these spacecraft to essentially do their jobs. And so my company, Phase 4, we focus on electric propulsion, which is, there's really these two tiers of propulsion in aerospace. You have chemical propulsion, which I think is what most people think about, big fire, hot, loud, a lot of energy rockets. And so those are high thrust, low efficiency. Generally, when you're dealing with a chemical propulsion system, you're firing for maybe a couple minutes at a time, and you get a huge kick out of it, and then you can just coast for a while. Whereas electric propulsion, which has been around for a couple decades now in a bunch of different forms, there's quite a few different systems of electric propulsion. Those are really low thrust systems, but they're extremely efficient, and that's what we work on. So kind of, if you can imagine maybe the weight of a piece of paper on your hand, I think that's a good analogy of maybe the amount of force that is applied from an electric propulsion system. And so it's not a lot of actual thrust, but if you're doing that maybe over the course of several months, several years, and you're firing for this really extreme amount of time, then that acceleration really adds up and you gain a ton of speed over time. And there's a lot of really famous missions that have utilized electric propulsion. In fact, most spacecraft that are interplanetary and don't have humans on board, those have definitely used electric propulsion, like New Horizons, the one that went to Pluto a couple of years ago. We had the Pluto flyby. That, I think, burned. It did a thrust maneuver for a couple months nonstop in order to get enough speed for it to get all the way out to Pluto. So that's kind of a background on electric propulsion. And again, I encourage you guys to kind of do some research. It's a pretty cool field, and there's a lot of really interesting applications for it. So our technology at Phase 4, here's an example of one of our thrusters. We're a supplier. We don't, this isn't a spacecraft, but just a part of a spacecraft. So we will develop a propulsion system, and say we have a customer that has a spacecraft that's maybe going to take imagery of Earth, and they know, okay, I need a propulsion system on board, rather than design my own, because propulsion is generally one of the more complex systems on a spacecraft. So rather than design their own, a lot of the time they'll reach out and find companies that develop them, and they'll purchase them as kind of plug and play systems. So here's an example of what one of our propulsion systems looks like, and it's this little package system. So we actually launched 2 of these about 20 days ago, and that was our first launch ever. So it's pretty cool. I'm still riding that high. It was a lot of fun. And so we're going to be doing the first fire here with those 2 units that are currently in orbit. And probably sometime this week we'll do the first fire. So that's pretty cool. Banana for scale, just so you can get a visualization. But again, there's so many different types of electric propulsion. Some are enormous, some are really small, different power requirements, different, it all kind of depends on what the mission is. So our facility, here's just some photos of where I work in our facility. Like I said, we're a pretty small company, so we try to make our facility work for us in a way that allows us to move quick and to be flexible and to rapidly iterate. So, again, if you're at a really large company, then maybe you have one really big program that you have a ton of people working on, and you can send parts out to a machine shop and on the other side of the country, or you have all these different facilities that are working together. Whereas we try to kind of have different stations at our office where we can build and we can design and we can test maybe R&D and development units to figure out how we want our units that are actually going to space to perform and operate. And so we do a lot of testing here. We do a lot of fabrication. So you can see in this middle image, here's a number of development thrusters. So these are non-flight. These are just the R&D dev thrusters that we've churned out over time. And I think our record is that we've built 40 different thrusters in 2 weeks at one point for development. And so this allows us to tweak a lot of knobs really quickly. We can say, okay, what if the tank's a little bigger? What if we change some geometry on these things, or turn these knobs here and there? And then we can immediately take those development thrusters that we build and turn around and put them in our vacuum chamber. Vacuum chamber is just pretty much a big like tank that you pull all the air out of, right? There's no gas in space, so we pull it to a vacuum, and that allows us to simulate space, at least in some ways. And so we can take these R&D thrusters that we rapidly develop and turn around and test them, and then we can go and I can send a file to one of my coworkers upstairs, and he can change some things, and we can, it allows us to move pretty quick, which I think is I think that's pretty unique for aerospace. And so yeah, it's a unique perspective, I think, but it's definitely really interesting because I feel like I've learned a ton. I've been at this company almost 4 years now, and I've just learned so much about engineering and the fundamentals of engineering by doing all this rapid work and getting, really being able to dip my toes in a lot of different things. So here's some more photos. Here's me working on a flight PCBA for one of those units that we launched a couple days ago. Here's what testing can look like sometimes. So here's us in a thermal vacuum chamber where we do hot fire ignitions in vacuum while we're thermal cycling it between maybe plus 150 degrees Fahrenheit to negative 40 degrees Fahrenheit. And so really extreme changes. Here is that launch that I was talking about 20 days ago. So it's called the Transporter 1 mission, which we recently flew on. It's pretty cool to watch the stream of that. Here's the actual payload stack of that launch. So me and a couple of my coworkers went down to Cape Canaveral, and we were in the payload processing facility where all of these spacecraft from a bunch of different countries were being integrated onto this one big stack. It was what's called a rideshare mission, where you have a lot of different, you have a lot of different teams who all have low mass spacecraft that you can put on the rocket. And here's a profile of one of our thrusters firing. In terms of career trajectories, if you guys are interested in aerospace, which you should be because it's really cool, it's a lot of fun. If you're maybe not ready to go to college yet, or if you're a junior, or you just want to kind of learn more about engineering, there's a lot of really great ways that you can get involved early, and maybe get excited about certain things like robotics clubs, science clubs. A lot of colleges have what's called a Formula One club, where you work on like developing race cars for competitions. I think at-home coding is also really great, and it's something that can definitely be started early when you're young with not a ton of resources needed. You can get Python open source, and if you have $60, you can go and buy a Raspberry Pi, and man, there are so many cool things that you can do with like a Raspberry Pi or an Arduino. So I really want to emphasize coding. It's awesome. You guys should definitely get involved with that if you can. And then also tinkering with mechanical systems. If you're interested in engineering, go home and ask your parents if you can take apart the weed whacker and figure out how it works. So when you do get to college, if you guys, say you are interested in aerospace and you say, Austin, what route should I take to end up in the aerospace industry? There's a lot of different things you can do, because spacecraft require electronics, and there's mechanical components, and there's software. A lot of times there's moving parts, and I probably should have put physics on here as well. Physics is a huge part of it. You're always going to need physicists to do the math. And so engineering, obviously, of which there are tens of different categories that you can go into: general engineering, electrical, mechanical, software sciences, computer science, coding, always important. Robotics and electromechanical systems, those are some big ones. And again, physics, plasma physics, astrophysics, there's general physics, the whole 9 yards. And then I also want to talk about kind of some different sectors in aerospace, because it is a really big industry. And I think a lot of the times people think about military and defense, whereas, there's plenty of different options if you're not interested in military and defense. So commercial space, which is what I do. I'm in the commercial sector, where, you have these for-profit companies that want to do missions in order to, achieve some goal and hopefully make a profit. And then you have government space, things like James Webb Telescope, things like, NASA programs. There's also aviation sector. So, the Boeings and, there's a lot of like really cool aviation R&D companies out there. And then if you want to go and work on programs like the F-35, obviously there's a huge demand for aerospace in the defense sector as well. So those are I think the big key sectors in aerospace. And at this time, if you guys have any questions, I would be happy to answer.
So for those, and looks like there's 11 people on, which is pretty cool. If you do have a question, you should be able to type it in the chat. And until I get some of those, I am going to ask Austin some questions. So like in your workplace, what are some like really important skills, not maybe on the knowledge side of things, but just like skills that you could learn at, at the high school level and perfect, I guess, as you get older?
Yeah, there's always fundamentals, right? Just engineering fundamentals is I think the thing that when you're in your career, you're going to want to lean on the most. Just having a good understanding of maybe how an engine works or how just electrical systems work. But I think that's something that, you really start to develop during college. So things that they can do now, pre-college, that are more accessible, I'd say, yeah, going back to coding, that's a huge one. Again, $60 for a Raspberry Pi, Python's open source. You can do a lot of really cool stuff. And I think, even things like woodworking, just learning how to visualize a design in your head and then tinker around with, okay, I'm going to need these parts and these parts and these parts, and I'm going to fasten it in this way. And I'm going to need, here's my list of materials, here, maybe a drawing, that sort of thing. So there's just practicing the mental design, going from mental design to execution. That's a huge thing that just doing that over and over, you're going to learn new skills every time you do that, and you're going to learn better ways to do that. And also, yeah, small engines, that's a lot of fun too. I think every engineer should at some point, take apart an engine, learn how it works, or, study a little like brushless motor or something like that.
Awesome. So we do have some questions in the chat right now. Do engineers ever get the chance to go to space?
Yeah, definitely. So there's kind of two main categories of astronaut. A lot of the time you have pilots who are generally military background for the most part. They don't have to be, but a lot of the time they're military background. And they're usually in charge of piloting the launch vehicle on ascent, or if it's if it's a capsule, they'll be in charge of re-entry, that sort of thing. But then most astronauts, I'd say like ballpark 2/3 to 3/4 of astronauts are what's called a specialist, where you have some background, whether it be engineering or medicine or biology or anything like that, really, and then you get selected to go to space. And space is really about experimenting, or at least our presence in space right now is about experimenting and conducting tests and science experiments, which allow us to learn more about the space environment. So if you think about ISS, there's definitely engineers that go to ISS for maintenance of the ISS, but also for different science projects that are maybe engineering centric. Maybe they want to test a space-based 3D printer or something like that. Then they'll definitely have engineers that go up. But I don't want to limit it just to engineers. There's also there's a lot of different backgrounds of astronauts that have flown.
Awesome. So another one that was in the chat says, and I'm not aware of this, but you probably are. Why do people age on Earth but not in space?
Why do people age on Earth? People do age in space. They definitely do. Although you are right, they do age a little bit more slowly. So Scott Kelly, who was, if you guys remember, he was one of the twins that, he was an astronaut that flew a couple years ago. He was in space for a full year, which I think is the longest that any person has been in space nonstop. And his twin on Earth, was kind of like the control of the experiment. And so technically, I think Scott Kelly is like a couple milliseconds younger than he was when he launched. As to the actual like physical reason why, I'm sorry, I won't. I could probably give an attempt, but I don't want to mislead you. So
Gotcha. So here's another question. What do you wish someone would have told you before you started in this pathway?
What do I wish someone would have told me? I wish that someone would have maybe showed me the different options that there are in aerospace, because I sort of went into it imagining, oh, you get an aerospace degree and you go work at NASA, and like, boom, that's it. And I didn't really know about this new space industry with all these companies that are doing all these smaller companies that are doing really cool things like Rocket Labs and SpaceX and Relativity Space and ourselves. I wasn't really aware that industry existed, and I kind of just fell into it. Out of school, I was looking for a job, and I got a job, and I was like, oh, this looks interesting, cool. And I've been here for 4 years now, and I absolutely love it, because it's not really what I expected. I expected to kind of have a slower pace aerospace job, but there's definitely a lot more out there than just NASA. If you don't want to do NASA, there's just so many options in aerospace, and it's also an accelerating industry. And I don't foresee us really ever in the long term or short term ever slowing down the growth in aerospace that we've been seeing in the past couple of years. And so more jobs are going to open up. There's going to be new technologies that are developed. And there's just a lot of stuff out there.
All right. And you probably expected this question, but this one just popped up. How much money do people in this field typically make?
Okay, yeah. So aerospace is, I think, one of the highest paying engineering career paths. I think maybe the top is either chemical engineering or like petroleum engineering. You know, Chevron's paying out the big bucks. But let's see, at bigger companies, you're pretty likely to get paid more than 100,000 a year. It kind of depends on where you live, right? I mean, cost of living in LA is going to be different than cost of living in somewhere like Denver. So, you know, greater than 100,000, that's not too uncommon. If you've been in the industry for a couple of years, you know, you have to be around for a little while and slowly, you know, or grow your skill set and work on different projects before you can advance. But a lot of the time, what a lot of bigger companies do, we don't do this, but most bigger aerospace companies have different tiers of engineering. So they're called like E1, E2, E3, et cetera, where I think E6 is generally kind of like a senior level engineer who's maybe getting ready to retire or whatever. And I think there's a lot of good online information about different pay ranges in those E1 through E6 gaps. So I guess we don't do the E system at our office, but I'd say I'm somewhere between an E2 and an E3 where I'm at now, and I'm just under about 100,000.
All right, awesome. So you mentioned earlier about, you know, I guess studies and engineering out in space is going to be here for a little while. What are some like upcoming technologies that would surprise people about like projects they're doing in space? I mean, that Starlink is pretty cool, you know, and a game changer, but what are some other things that you see in the future?
Yeah, I mean, there's a lot of pretty cool stuff. One of the big ones is 3D printing in space. You know, a big dilemma for launching things to orbit is just mass, right? If you have you know, you have a spacecraft that you need to waste mass on a structure that allows, you know, all the really sensitive scientific equipment to be safe during launch. You know, you want to find ways to avoid having to launch that mass, because I think the rate is something like for every 2.5 pounds that you send to orbit, it's like $10,000. So, you know, it's a huge price tag to put things into space. And so 3D printing in space opens up a lot of really cool use cases where maybe instead of sending a whole spacecraft that takes up this enormous volume, you can just send a hunk of aluminum or a hunk of titanium or something and do the printing in space and let the spacecraft kind of build itself out over a couple years, weeks, months on orbit. And then that, you know, really optimizes the amount of stuff that you can send up. Another really cool one, I think a lot of you probably know that we're looking at the moon again. So we're going to try to send people to the moon. I would guess in the next decade, we'll probably have another person on the moon. There's a lot of companies like ULA is one of them that's looking at having a in-orbit moon base, kind of like the ISS, but instead of in orbit around Earth, you have one in orbit around the moon. And so that, again, opens up a lot of really cool use cases where maybe that's, you know, a jumping off point for another mission to a further away planet. And then let's see, another cool technology that we're maybe a little further away from, but, you know, people are still definitely working on it, is mining. There's a lot of resources in space. You know, asteroids have minerals, they have methane, they have these things that materials that you can turn into fuel, or materials that you can use for, you know, a lot of different things on Earth. And so asteroid mining opens up a ton of possibilities if you can find a way to do it efficiently. And yeah, I think that's probably a technology that we're, of the three, we're the furthest away from that one, but we're definitely moving in the right direction.
Awesome. It's interesting because I think we've only got a couple minutes left, but a former Yelm student, I'm not sure if you went to school with him or not, but he's working or finishing up his PhD in material science, doing a lot of 3D printing for, you know, aircraft and spacecraft and stuff. So
yeah, 3D printing is definitely getting huge. If you guys are interested in that, you could look up a company called Relativity Space. They're also based in LA, but they're a big 3D printing company, not for in orbit 3D printing, but right now they're focusing on 3D printing rocket engines, because right now, if you know, rocket engines are a very complex technology, and it, especially when you're launching a ton of stuff like SpaceX is, it becomes not very cost effective if you have to do this huge, crazy assembly for every booster that you want to build. And so if you can 3D print it and then post-process it afterwards, that has a lot of potential to save time and save money and save materials, and it's pretty cool.
that's awesome. That's awesome. All right. Well, any final remarks or anything that
I would say just study hard, and you know, if you guys are able to, you know, go to school and go try something new, and whether that be engineering or whether that be getting an engineering major or a computer science major, or maybe just join a club, you know, there's a lot, every school has cool engineering clubs and just ways that you can develop your skill set. And you know, I think that learning by doing is, at least for me, that has helped me a lot. You know, it's one thing to read a book and to learn about, you know, maybe how a certain technology works, but if you can actually build it and tinker with it and iterate and try different things, you know, that's I think where you learn the most.
All right. Well, thank you very much, Austin, for taking time out of your day and kind of giving back to the students here at Yelm. And we appreciate your advice, and hopefully we'll find other opportunities to tap into your knowledge and resources in the future.
Sure. Yeah, I'm happy to be here. And again, feel free to email me. I have my email up there on the screen. Yeah, it's great talking to you guys. Go Tornadoes.